Hello everyone, I'm Ruel B. Brondo, a student from Bicol University. So I am here to present to you the Taylor's polynomial. Let us first define what is a polynomial. A polynomial is an expression of the form a sub 0 plus a sub 1 plus a sub 1 x plus a sub 2 x squared plus a sub 3 x cubed plus ellipsis up to a sub n x raised to n, where n is a whole number and the coefficients a sub 0, a sub 1, a sub 2, a sub 3, a sub n must be constant. So that is a polynomial. Okay? Let us now start. Let us now define a Taylor polynomial. A Taylor polynomial for f of order n about the point A is the polynomial defined by the formula p sub n x is equal to the summation from k is equal to 0 up to n f raised to k times the quantity of a all over k factorial all over times the quantity of x minus a raised to the k. So that is now the formula in finding the Taylor polynomial. So let us now start. A Taylor series is an idea used in computer science, calculus, and other kinds of higher level mathematics. It is a series that can be used to create, estimate, or guess of what a functions look like. So the idea of a Taylor functions are polynomials that are simpler than the most other functions. This leads to the idea of approximation of a complicated function by a polynomial. Given an example, consider the polynomial function f of x. F of x is equal to 5 x to the fourth minus 5 x squared plus 5x cubed plus 2x squared plus 4x plus 1. This is 2x squared. So this is the given polynomial function. So we are asked to find the Taylor's polynomial. By using the formula, we can create a 5 columns. So to do that, we will erase this one. Okay, let's go back to our example. F of x is equal to x to the fourth minus 5x cubed plus 2x squared plus 4x plus 1. So as I have said a while ago, we need to find the Taylor's polynomial by using the formula. But to do that, we need first to identify the value of n and the value of k. Okay, what is the value of n? What is the value of a? To identify the value of n is the degree of the polynomial function. Since the highest exponent is 4, so n is equal to 4, and it is in the 4th degree. So n is equal to 4. And k stands for the leading coefficient. So a is equal to 1. Okay, so we can now create 5 columns by using the formula. So the first column will be k. K will start from 0 up to the degree of 4. So from 0 to 4. Then the next column will be f raised to k, the quantity of x, or we need to find the derivative of this polynomial function. For k is equal to 0, we just need to copy the polynomial function x to the fourth minus 5x cubed, which is here, plus 2x squared plus 4x plus 1. Okay. Then we find, if k is equal to 1, we need to find the first derivative. So to get the derivative of this function, we have 4x cubed minus 15 minus 15x squared plus 4x plus 4. Okay. Okay, this is the first derivative of this function is 4x cubed minus 15x squared plus 4x plus 4. Then if k is equal to 2, we need to find the second derivative of this function. So we have 12x squared minus 30x plus 4. Okay, so we are now we need to find the the derivative of this function, this polynomial function, if k is equal to 3. So find the derivative of 12x squared minus 30x plus 4. And that is 24x minus 30. Okay. And the derivative of 24x minus 30 is equal to 24. So we just need to find the derivative of each function. So for the third column, so on the first column, we just need to find the derivative. For the third column, we have f raised to k times the quantity of a. Okay, since a is equal to 1, as we have identified a while ago, a is equal to 1, we just need to plug in the value of a, which is 1, to the function on the second column. So this will be 1 to the 4th minus, and that is 1. 1 to the 4th is 1. Minus 5, 1 cube, that is 5. Since 1 cube is 1, 1 times 5 is 5. Plus 1 squared, this will be 1 squared. 1 times 2 is positive 2. Then add 4, this will be equal to 1 since x is equal to 1. 4 times 1 is 4. Then we will add positive 1. So 1 minus 5 is negative 4. Negative 4 plus 2 is negative 2. Negative 2 plus positive 4 is positive 2. Then positive 2 plus 1 is equal to 3. So for the we have positive 3. So in the f raised to k times the quantity of a. Next, we will repeat the same step. We just plug in or substitute direct substitution of this function, polynomial function. So we have 4 times the quantity of 1 cube, that is 4, minus 15 because 1 squared is 1. 1 times 15 is 15. Plus 4 times 1 is 4. Plus 4, so we need to add. 4 minus 15 is negative 11. Negative 11 plus 4 is negative 7. And negative 7 plus 4 is equal to negative 3. So we have here the value of negative 3. Okay. So again, we will repeat the same step. This will be 1 squared. 1 squared, 1 times 12 is 12. 12 minus 30 times 1 is 30. Then plus 4. 12 minus 30 is negative 18. Negative 18 plus 4 is negative 14. So we have negative 14. Okay? Negative 14. So repeat the same step. 24 times 1 is 24. Since x is equal to 1, 24 minus 30 is equal to negative 6. 24 minus 30 is equal to negative 6. So we just copy the 24 here. Okay? For the fourth columns, yan. For the fourth column, we need to find the f raised to k times the quantity of a all over x factorial. Okay. So the answer on the third column is 3. So we just need to copy, since this is the numerator, f raised to k times the quantity of a all over k factorial. K is equal to 0, so we have 0 factorial. Since 0 factorial is equal to 1, so we have a denominator of 1. 0 factorial is equal to 1. So 3 divided by 1 is equal to 3. Okay, 3 divided by 1 is equal to 3. So we come back. So this will be the numerator. The answer on the third column will be the numerator, negative 3 all over k factorial. Since k is equal to 1, so we have 1 factorial. Negative 3 divided by 1 factorial is equal to positive 1 or 1. Negative 3 divided by 1 is equal to negative 3. So we have negative 3. Okay? This will be the numerator, negative 14 all over k factorial. The value of k is equal to positive 2. So we have 2 factorial. And 2 factorial is simply 2 times 1. So negative 14 divided by 2 factorial, which is equal to 2, since 2 times 1 is 2. So that is 2. Negative 14 divided by 2 is equal to negative 7. Okay? So this will be the numerator. Your answer in the third column will be the numerator of the to the fourth column. So we have negative 6 all over 3 factorial since k is now equal to 3. So we have 3 factorial. By the way, 3 factorial is simply 3 times 2 times 1. So 3 times 2 times 1 is equal to 6. So we have negative 6. The denominator is 3 factorial. 3 times 2 times 1 is equal to 6. So negative 6 divided by 6 is equal to negative 1. Okay? So the numerator will be 24 all over the value of k is equal to 4. So we have 4 factorial. And 4 factorial is simply 4 times 3 times 2 times 1. And 4 factorial is equal to 24. Okay, we just need to copy the numerator. And we divide 24 by 24. That is equal to positive 1. Okay, we have just copied the answer from the fourth column, f raised to k times 8 all over k factorial. The answers are 3, negative 3, negative 7, negative 1, and positive 1. So for the last column, we need to find the summation of f raised to k times a all over k factorial times the quantity of x minus a raised to k from 0 or k is equal to 0 up to 4. Since n is equal to 4. So we will just copy the answer on the fourth column, which is 3. 3 times the quantity of x minus a. A is equal to 1. Raised to the k. K is equal to 1. Is equal to 0. Since the first value of k is equal to 0 a while ago. So we have, for the second column, we just copied the answer. Negative 3 times the quantity of x minus a is equal to 1. So we have 1 here. Raised to the k power. Since the second value of k is positive 1, so the exponent will be positive 1. Or the value for k here is positive 1. So we have to copy the answer, negative 7, since this is on the formula, times the quantity of x minus 1, since a is equal to 1, and raised to the k power, that is equal to 2, since the third value of k is now equal to 2. So we have negative 7 times the quantity of x minus 1 squared. So we have to copy again the answer, since this is on the formula, negative 1 times the quantity of x minus a is equal to 1, so x minus 1 raised to the third power. Okay, so the value of k on the fourth column is 3. Copy again, positive 1 times the quantity of x minus 1, since a is equal to 1, raised to the k power. So that is, for the last column, we have n is equal to 4. Okay, so this will be now, we need to find the summation of these answers on the last column. So for piece of nx, or the Taylor's polynomial, we have 3 times the quantity of x minus 1 raised to the 0 power, negative 3 times the quantity of x minus 1 raised to the first power, minus 7 times the quantity of x minus 1 squared, minus 1 times the quantity of x minus 1 raised to the third power. Okay, plus 1 times the quantity of x minus 1 raised to the fourth power. Okay, this will be now the answer for the Taylor's polynomial. So we can further simplify this polynomial function for us to know if our answer is correct. So we will just need to simplify this piece of nx, or the polynomial function, or the Taylor's polynomial. Okay.